Hi friends, welcome to my YouTube channels. So today new day, new problems. Again I came for new problems here force and bending moment diagram for simply supported beam. So here they given two UDL AC and DB 10 kilonewton per meter, 5 kilonewton per meter or 2 Newton, 2 meter and 3 meter. So what we have to do before solving this we have to find the support reactions only. So simply supported beam we have to find the support reaction. So let us start this work. So sigma FB equal to 0. That means summation of all the vertical forces equal to 0. That means we'll take total upward force equal to total downward force. What is total upward force? RA plus RB is upward force. Then what is downward force? This 2 UDL. So UDL now we have to convert into load. So 10 into 3 first one plus 5 into 2. 5 into 2. So 2 load is there. So give equations number 1. Now take the moment about A. That means we'll take clockwise is equal to anti-clockwise. Total clockwise is equal to total anti-clockwise will take. So taking moment about A. So 10 into 3. Right here 10 into 3 load, then half distance what is 3 by 2 plus taking moment about A. So UDL is connected. Now this UDL 5 into 2 load first. What is this one? 5 into 2 load. Then 2 by 2 half distance. But where is this UDL from this our point A? 3 plus 2 5 meter away. So 5 plus 2 by 2. This is the way to calculate the UDL. Suppose I already previous video I discussed. Suppose I'll draw the point load diagram, new load diagram for this. You see here again I'm showing here. This like this is there, no? Like this is there. If you draw the load diagram here 10, here 5. This is 3 here, 2 here, 2. So how we'll draw the load diagram? See this quickly. Load diagram is already you know maximum deflections will be middle. So middle only will be the load. 10 into 3 load. Then this distance is 1.5. This distance is 1.5. Now here load will be the middle. So load will be 5 into 2 and distance will be 1, 1. If you take the moment about A, now look here. So this is the what is 10 into 3, 10 into 3 into 1.5. Is there 10 into 3 into 1.5. Suppose this again another load. This is the UDL. This is clockwise. What is this one? Load 5 into 2 into 3 plus 2. 5 plus 1, 6. 5 plus 1, 6. Either you write here 10 is to 3 into 1.5 plus 5 into 2 into total distance. Total distance this how much? 3 to 5 plus 1, 6. 5 plus 1, 6. Either this way you find the moment or you know this one. So clockwise, anti-clock will be RB into total distance 3.7. So this way you can find the support reaction. So look at here, load UDL we converted into load diagram. Load diagram always will be middle. Why? Because total deflections will be total deflections. See this middle. Maximum deflections will be in the middle. Maximum deflections middle. So that means load will act in this middle. Load will act in the middle. So 10 into 3 into 1.5. 5 into 2 load into total distance. So this way. And this way also suppose UDL is rectangular load. So we are taking half distance. Load into half distance. Load into half distance. But we are taking moment about A. So where is the UDL? After 5 meters. So 5 plus 2 by 2. Or this way. Which way you are comfortable, you find the support reactions. Okay. So support reactions we don't know. So RA and RB will calculate, you will get the value. If it's calculate RA here, RB here, substitute there, you will get RA and RB value. So RA you are getting here, RA 25 kilonewton and RB you are getting, RB, where is RB? RA and RB will be 15 kilonewton. So if you will solve this, you will get RA and RB, okay? These calculations you have to take care. Now shear force diagram calculation. So we'll extend this line, we'll draw the shear force calculations and we'll draw the diagram. Thin line you have to draw, so it will be easy for us. Thin line you draw the all thin lines, draw the shear force 0 line. This is the shear force for, in this line shear force will be 0. In this line shear force will be 0. So what is sign conventions we are following here? This is the section. It will take right side, downward force will be positive. If we will take left side, upward force will be positive. Reverse, downward force, this is the section, upward force, this will be the negative. These are the sign conventions we are following here. Okay, and for the UDL, shear force diagram will be inclined line. For UDL, shear force line will be inclined line. This concept we need. So now we'll go the shear force diagram calculation. Shear force diagram calculation. So look at here. Point A, we are taking left side, upward force. Upward force will be, so write this value here, how much? RA 25. What is RB? 15 kilonewton. So not wrote, okay? Kilonewton. So what is SA? Left side, upward force positive 25. Now SC. So upward force is how much? Positive. Then downward force negative. Downward force left side, how much force this is? 10 into 3. 10 into 3. 30. So minus 5 kilonewton. Shear force will be, this also write kilonewton. Unit also write always kilonewton. So SC, 5 kilonewton. Now SD. Till SD, no load in between C and D. So same will be minus 5 kilonewton. Then SB. Here you see SB taking left from this side. No, so we will take L. L means what will happen here? This point load, the reaction force will not come. Before this point will take, UDL only will come. So how much SD here? Minus 5, and downward force will be negative. Minus 10. 5 into 2, so 10. So it will come minus 15. If we will take SBR, R means now this RB will come. So what will come? Minus 15 equal to plus 15, because this is going upward force. Upward force from left side positive, downward force negative. So 0. So shear force at B will be 0. Now we'll draw shear force diagram. So first up to A point, what is? 25. Now inclined line should be there. C. SC will be minus 5. So it will come somewhere here. So we'll draw this. So this is the 25A, this is 5, this is 25. You write 25 here A, this is 25. So this point C, bending moment will be 0. Some point will give E. So at E point, shear force will be 0. Okay, now in this point C and D, no load. So we'll draw the horizontal line. No load means horizontal line. UDL means inclined line we draw. Now again UDL is there. So how much this here? Minus 15. SBL. So SBL will be minus 15. So here inclined line, because this is UDL. So inclined line. Now this point 0B. So this is the shear force diagram for particular problem. Shear force diagram. This is shear force diagrams. Okay. So this is coming positive This is coming negative, this is negative, okay? So negative. Now, bending moment diagram we have to draw. Already this section, zero shear force, bending moment will come maximum. Once we'll do the calculations, we'll see. Okay, so this all lines and all, draw the projection line like, so it will be helpful to write the value in that particular point. So always we have to draw this light line or different color lines and zero. Okay, now bending moment diagram calculation. Okay, so if we'll see, bending moment at A will be 0 and bending moment at B will be 0. So in this point we'll take moment, will become 0, B point also will come 0. So in between we have to find out. So bending moment at C. So for these sign conventions we have to write. Take the section, see this is clockwise, negative. Then this is anti-clockwise. This is left side, this is right side. Now reverse. This is clockwise. Now this is anti-clockwise. This is clockwise, this is anti-clockwise. And this is anti-clockwise, this is clockwise. This will be plus, positive, and left side, right side. So which way we'll take? We'll see. So now we are taking from the left, this side, no, left side. So this point RA, 25 into 25. This is going, what is? Clockwise, positive. So this is clockwise going, positive. 25 into 3 minus, this coming minus, left side, anti-clockwise, negative. So 10 into 3. 10 into 3 load. Then 3 by 2. 3 by 2. So MC how much will come? We'll see this here. Value we calculated. So which questions we are drawing? MC not calculated. Okay, MC not calculated. Now we'll calculate this value. How much? 75 minus 10 into 3 into 1.5. 10 into 3 into 1.5. 10 into 3 into 1.5 is coming 45. So 45. So 75 minus 45 minus 75 is coming 30. 30 kilonewton meter. Okay, now because moment unit is kilonewton meter. Now what we'll do now, this point maximum value is E. So this distance we need. This distance we assume x. We need that distance is x. So we draw this. So this is how much? 25. This distance we assume x. Then total distance is 3. So 3 minus x, this is 5. So how to calculate this distance? So x by 25 is equal to 3 minus x by 5. If we'll calculate. So what we can write? 5 ja 25. So x equal to 15 minus 5x. So 5 3 8x equal to 15. That means 8 is equal to 15. 6x. X equal to, see this 5 5 ja 5 5 15, 15 minus 5x. Okay, so 6x, 15 divided by 6 coming 2.5. So x equal to 2.5 meter. We know the x equal to 2.5 meter. So now mx value we'll find. Mx equal to, suppose this x, no, what is this mx value? So 25 in 25x, just write 25x minus 10 into x load into x by 2. So this is the x. Now if you want to this x equal to 2.5, we will substitute here m 2.5. How much will come? 25 into 2.5 minus 10 into 2.5 into 2.5 by 2. So you will get this value m 2.5 I calculated. We will see how much value m 2.5 na. It will come in 31.25. 31.25 kilonewton meter. This is the maximum bending moment we know. This is the maximum bending moment we know. Now space, we will see here. I will draw here MD, moment of inertia of the MD, the bending moment of MD, this point, how much is coming. So MD is equal to nothing but, if you will see from the right side, so what will come? Because left side will take long with their 1, 2. So here only 1. So RB 15 into 2 minus 5 into 2 into 2 by 2. So this how much is coming? It's coming 20 kilonewton meter. 20 kilonewton meter. So this MD once you are taking, you can take this side also. But this side little long calculation. So already D na right side will take. Right side na 15. What is this one? 15 going anti-clockwise. This is anti-clockwise, positive. Then this coming clockwise, negative. So 20 kilonewton MD we got now. So now we'll draw the shear force and bending moment diagram now. So see here. This diagram, zero line first, zero moment diagrams you draw. Zero line. In this line, bending moment will be 0. So first maximum bending, UDL is there. Maximum bending moment will be in this point. How much maximum bending? 31.25. Now, what is this point? C. MC somewhere calculated? Yes, 30. So this also curve line only. Curve line only. 30 exact. Okay, 30. Now here no load. So here will be the at point D. At point D 20. So this will be the inclined line. This will be the inclined line. So for UDL bending moment diagram is parabola. For no load inclined line. So we dot inclined line. Again here what is the bending moment at point B will be 0. So make the curve line. Make the curve line. This is curve line. This is straight line. This is curve line up to this curve line. So here this is straight line. This is curve. Parabola line. Okay, this little draw the taper. This is the bending moment diagram. So if we'll have this part is known as bending moment diagram. So this is known as bending moment diagram. So look here, what you have to remember, this sign convention, UDL for inclined line, no load horizontal line, for UDL parabola line, this is straight line because no load here, no UDL, no load, and curve line because his UDL is there. So this way we can solve the problem, and maximum bending moment will be, if they will ask me, wherever the shear force will be 0, where will the shear force will be 0, we'll find the distance in this method. So see this triangle 25, 5. So 25, this side 5. This is distance x we assume. So x by 25 by 3 minus x by 5. This way we can calculate the x equal to 2.5. At point 2.5 we calculated the bending moment. So at point x what is? 25 into x into 10 into x by 2. This is the general calculus, bending moment calculation. So here we substituted value, we got this value. So okay, suppose MC how much? 3. If you substitute here 3 also, so the same this will come. This 30 you can get. Because MC I calculated this way, 3. See here, if x equal to 3, 3, 10 into 3 into 3 by 2. So that way also you can calculate. Okay. Okay, students, watch the video, subscribe the channel, share this video to your friends. Okay. Thank you.